Dear students, we are moving towards the third part of the chapter Gravitation, in which today we are going to learn about the universal circular motion or the magnitude of centripetal force. First of all, we will talk about the circular motion. If any particular object is rotating in the circular orbit, suppose if any one particular object which is labeled as A is moving in a circular orbit, then the motion of this particular object A will be called as a circular motion. Now here, if you will see, there is another word in it, that is a uniform. It means what? A particular object, when it travels the equal distance, if it is traveling a equal distance in an equal interval of time, then we call it as a constant speed. Means if I'm talking about the uniform circular motion, then if a particular object which is performing a circular motion and completes equal number of rotation in equal interval of time, then the motion will be called as uniform circular motion. The next part is, in our previous topics already we had studied about the centripetal force, the force which is acting towards the center of the circular motion is called as the centripetal force, and the formula for it as F is equal to mv square upon r. Now if I am talking about one of the object whose mass is m and it's performing the circular motion, and the radius of that circle in which it's performing its motion is r, then the formula can be written as F is equal to mv square upon r. Further part is speed is equal to distance traveled upon time taken. That formula already we know. Now if I'm talking about the circular motion, then the distance traveled in a one revolution will be nothing but 2 pi r. It will be a 2 pi r, which is nothing but the circumference or the perimeter of the circle. And the time taken to complete that one revolution is capital T. Then the velocity or the speed we can write as a 2 pi r upon t. Now the next is, if I'm labeling the equations over here, this equation as a 1 and this equation as a 2. So now when I will substitute equation number 2 in equation number 1, I will be getting this form, because F is equal to mv square upon r, that I can write as a 2m into 2 pi r upon t the whole square upon r, which on simplification I will be getting this after opening the brackets and keep bringing that t down. Further is, the next part is, in your textbook there is a one correction. They have given an equal sign which I had already marked over here. This you have to make it as a multiplication. It's not the equal sign, it's a multiplication. And on solving all these factors and then bringing this factor, this is nothing but like a constant which we got in the Kepler's third law. There we studied, that is the square of a period of revolution of the planet around the sun is directly proportional to the cube of the mean distance of the planet and sun. So in this, on solving, we are getting F is equal to 4 m pi square upon r square nk. Now in this, the entire terms, this terms which is present in this formula is a constant value. It means here if I am writing, I can write F is equal to constant upon r square. It means what? If I am looking between this two, F and r square, they are inversely proportional. They are inversely proportional, and that's why here the Newton concluded Newton concluded in this line, that is, Newton concluded that the centripetal force, which is the force acting on the planet and is responsible for the circular motion, must be inversely proportional to the square of the distance between the planet and sun. So this is the explanation for that, why the square was taken, and which is also called as the inverse square law of gravitation. You can see over here, inverse square law of gravitation. The next part what we have to study is some numericals they have given that we can discuss later on. You can go through them and then later on we can discuss. Now the next, another phenomena of the nature which we call as the low and high tides. You might have observed that in a monsoon season, the municipal government, the BMC, they are giving the high tide timings and the what will be the height of the tides in the sea. So they are calculating all this, or this phenomena is explained by this Newton's law, which already we have studied, the universal law of gravitation. And this is all the combined effect of the gravity of the earth, gravitational force of the moon and the sun. The combined effect of that brings the changes in the level of the sea. In this, when the sun and moon in one line, suppose this is the position of a sun, earth and moon, they all are in a one line, then in that case the water will be attracted towards the equator, means this positions. Water will be attracted more because the one side moon and the one side sun, they will attract the water, and then the level of water in the sea will rise at this particular places. That will be called as the high tides, and it will be much higher if the sun is on the same side. Suppose if the sun is here at this place, then in that case so in this case we will observe that the earth and sun and moon, if they are in a one line, then in this case there will be a high tide of with a maximum height in the level of water in the sea. If the sun is not present over here, sun is present somewhere here at a 90-degree, then this both the positions will have almost a equal amount of water, means it will be a moderate tide in the sea. Now you can go through this paragraph in your textbook. Then the further part what we have to study, that is the earth gravitational force. The earth's gravitational force is nothing but what, if we are having an example of the stone, if we are throwing the stone upward in the sky, then it goes up to a certain height and then it returns back. So till that force acting on it and it's not balancing with the gravity of the earth, stone keep on going upward. Once it's balanced with the gravity, then the velocity becomes zero and stone starts falling downward towards the earth. And this force by which it's coming downward is directly or directed towards the center of the earth. The further part is, they have mentioned over here, you can see the earth attracts every object near it towards its because of the gravitational force, and the mass of this is towards at the center. So gravitational force on any object due to earth is always directed towards the center of the earth. Further again, they have given some of the solved examples over here that you can go through, and later on we will discuss about all this. The next part we will study about the earth's gravitational acceleration.